Hello guys, welcome to Tech Alpha Anju, and this is the video for support vector mission. And in previous video we talk about logistic regression, and before that linear regression, and then we took a short notes on supervised models. So now we're going to see what is the support vector mission, why we are using support vector mission, and what is the uses of support vector mission, and what is the Python programming on it, and where we are implementing that super vector mission in programming. So for that, first of all, you have to subscribe to my channel. Then you have to click that like icon and share icon. And if you want to know anything, or if you want to ask any questions, please comment down. And now let's dive into our topic, guys. Before that, I want to ask you one thing. Really, it's so painful, and also it's so hard work, and now I'm realizing it's very hard work. So I hope you will understand, and please do subscribe and comment and share, please guys. So let's dive into our topic. So first we'll understand what is support vector mission. So let's start our video by understanding what is support vector mission and where we are using it and why we are using it. So now let's dive into our topic. So guys, I hope you will understand. And what is support vector mission? Support vector mission is supervised machine learning model. So it is a supervised learning model. It is used in both linear regression and also logistic regression, but mainly used for logistic regression. So so I told you now, it is used in classification and regression. In regression, it is used less common, and the main goal is to find the best boundary hyperplane that separates the different classes. So where, for example, we can think we can imagine two groups are there. Two groups. Here I given the example. Two groups are there. First one is blue flower and second one is red flower. So we have to do a good fit, we have to separate them. So we'll take two classes, class A and class B, and middle we'll put one margin. Margin is a boundary, where hyperplane. Margin is a hyperplane. So you will separate, like if this is look like blue flowers, means it will be in class A. If it look like red flower, means it will be in class B. So SVM draws, super vector mission draws the best line between them to separate the classes. Hyperplane is just a margin, means just a best boundary. Boundary means just a straight line between two classes, which separates the classes. Just now I told blue flowers and also red flower. In middle there is a hyperplane which is separate both flowers, both classes. So this is the example for support vector mission. I hope you understand that. So it is also a machine learning algorithm where it is having the classification models and regression models. In regression models, it uses less common, and it mainly goal is to find the best boundary. Best boundary is also known as hyperplane, and that separates the different classes. And I will do about the example also. So why do we use support vector mission? So we have to understand why we have to use support vector mission. So data has clear class separation. If you use separate classes, means data has clear cut separation, right? We can understand what is the class A, class B. If we take separation, means you can understand easily. Okay, this class A belongs to this one. This class B belongs to this one, like that. So high dimensional data. Yeah, high dimensional data. It has high dimensional data and text classification. It also classifies the text classification and image classification. Image also it will be classified, and face recognition. Everyone has different features, so it will one second, guys. So it will just what it will do, it will also classify the face recognition. So now we are going concept like hyperplane. Hyperplane is a decision boundary. Just now I told what is a decision boundary, where there is a one line between two classes or three classes and many classes, multi classes also. There we can do hyperplane. Na? So for example, we'll take blue points, red points. In middle we'll put hyperplane to separate that red points and blue points. And we can see what is support vectors. Okay, support vector missions. Support vector. What is support vector? Without knowing that, we can't implement program, right? What is support vectors? Support vectors is a closest data points to the hyperplane. Closest data points to the hyperplane means class A contains some of the data points, right? Class B contains some of the data points. So it is closest to the hyperplane. It is called as data points. So support vectors are the closest data points to the hyperplane. So these points are most important because they determine the position of the boundary. these points are very important because they only determine the boundary position, right? They can only, this boundary or that boundary, they can only decide. So these data points are very important in the support vector mission. So if the interview asks, if your interview asks means, you can simply say like support vectors or the data points, which is near, one second, which is nearest to the decision boundary. They help define the optimal hyperplane. So it is usually 0.5. So now we are going to see some interview questions, very important. They ask in interview. So they'll ask like, what is regression? Now what is regression means? It is a supervised learning model. It is used for classification problems and predicts the probability of the data between the 0 and 1. And why it is called regression? If it is classification means it is called because of we use the probabilities by using the sigmoid function. So final output class will be labeled. What is sigmoid function means? It is a mathematical function which converts the probability into the which converts the prediction values into the probability between 0 and 1. So what is the output of logistic regression? What is the output of logistic regression is probability of 0 and 1. So the difference between linear and logistic regression is very common. Linear is numerical, logistic classification. And what metrics are used? Now we use accuracy metrics, and we can use perception, we can use recall, F1 score, and ROC AUV. We can see these all in coming videos. We can see precision, recall, F1 score, and ROC AUV. So this is all about logistic regression. I hope you will understand. So today we learned logistic regression, a supervised machine learning model, and it is used to classify the tasks. Unlike linear regression, it predicts the category list, such as it predicts the fake or not, and also it predicts the pass or fail, and it predicts the disease there or not, like that. So logistic regression, which uses sigmoid function, and it converts the predict value into the probability values, which is 0 and 1. And because of its simplicity and speed and interpretability, it is very famous, and it remains one of the most widely used classification algorithm in machine learning. So logistic regression is a supervised machine learning algorithm used for classification models to predict the probabilities of the data point belonging to the particular class. So this is all about linear regression model, and I hope you understand what is the linear regression and what is the logistic regression. Now we are going to see support vector mission. It is also most widely used concept, and it is basically comes for the both linear regression and logistic regression, but mainly used for the classification models. So next we are going to see what is the linear regression, what is the logistic already we finished, right? So next we are going to see what is the support vector mission. Thank you for watching, and I hope you will subscribe my channel, and if I do any mistakes, please comment down and that I can improve. So this is Anjali signing off. Tech Alpha Anju. So you can simply say kernel helps support vector machine handle non-linear data. So it will handle the non-linear data by transforming it into the higher dimensional space. So okay, here non-linear data which is not accessible for taking the straight line, it is uses the kernel for handle the data by transforming it into the high dimensional space. So I think you will understand that. So now we'll see something like real-time applications, and the real-time applications such as email snap detection where input is email content and the output is snap and not snap. Means fake or not fake. We will give input like email content, it will generate output like a fake or not fake. So now we'll see in facial recognition, it will give facial features, and the person it will detect like a, if you give one facial, if I give my facial feature means it will detect like a person A, and if you give other features means it will give a person B, and other features means person C, like that it will be used. So detection, disease prediction also same. Medical records, disease will give medical records, it will detect by disease and non-disease. And here we will use iris dataset example, same example, and we have some features, sepal length, sepal width, petal length, petal width, and we need to classify that by different types of flower species like setosa and versicolor and virginica. And the Python programming is something like this, and Python programming for every concept I told you now. Linear regression is basic model, with that only all the other algorithms are formed, and the code for everything is similar only, but somewhat different in a little format. So we'll discuss one line by line the code. So first we imported iris. One second. First we imported iris, and second we took a time test split, and then we took a support vector machine, and matrix accuracy score only we are using here, and we are loading data set. And after loading data sets, we are taking X data and Y data. Y data is target value, X data is data. And we are splitting data here. We are splitting data, and then we are creating a model like a SVM, which is kernel is linear. If we want kernel non-linear means we can give kernel is equal to non-linear. And train model, we are training the model by fitting data. So predicting the model X data, and then we are taking accuracy score also. So this one is the Python code for the Python code for the support vector machine using the iris dataset. And the sample output will come like 1.0. You know that what is 1.0. 1.0 means it is 100%. The model correctly classified all the test samples. So now we'll see. Now I will explain fastly because I have no time. I have to go early now. So the advantages works well with the small data sets, and yeah, it works with the small data set, and it is efficient in high dimensions. I told you now maximum margin means it is very efficient data, so it's using dimensions, high dimensions. So it will give good accuracy, and it will handle the complex data using kernels and less overfitting compared to some algorithms. So disadvantages are slow on very large data set and difficult to interpret, and choosing the right kernel can be challenging. And then higher computational cost. Yeah, it has higher computational cost. So yeah, this is all about support vector machine. And if you go for interview means they'll ask some questions like what is support vector machine, and what are support vectors. Support vectors are nothing but closest data points which is near to the decision boundary and determine the position of the hyperplane. What is hyperplane? Hyperplane is a decision boundary used to separate the different classes. What is margin? Margin is different between the hyperplane and also the nearest support vectors. What is kernel trick? If there is a non-linear data into higher dimension space where it can be separated linearly, and difference between logistic regression and support vector machine. And yeah, this is all about support vector machine. So today we learned support vector machine, a very powerful supervised learning algorithm. So it is mainly used for classification task, and somewhere we can use in regression task also. And SVM mainly it's finding the optical hyperplane that separates classes with the maximum margins, and the nearest points to this boundary are called as support vectors. Yeah, nearest data points, nearest or closest data points of the margin is known as support vectors. Support vector machine is widely used in image classification and face recognition, and also snap detection, and also many other medical diagnosis, etc. And because of its high accuracy and ability to handle the complex data, it is using the kernels. So it is about support vector machine. Support vector machine is a supervised algorithm that finds the optical hyperplane, and also with maximum margin to classify data points into different classes. So I hope you understand. And this is all about support vector machine. And please subscribe to my channel. And next video is coming on k nearest, and also it's coming on decision tree and random forest. Then later we'll discuss on unsupervised learning model. So I hope you will understand. And if I done any mistake, please comment me down. I will try to improve that. And if you have any doubts, and if you want to do clarification means, please comment me down, and don't forget to subscribe. And this is Anjali, and this is your channel Tech Alpha Anju, signing off. Thank you.